The issue at hand concerns the length of service entrance conductors in a large commercial service, rated at 1600 amps. With the installation about 80% complete, the authority having jurisdiction, or UJ, has determined that the service entrance conductors are too long, necessitating an external disconnect. The AHJ concern about the disconnect being too far from the equipment is valid, as they are responsible for ensuring public safety. Consider this situation and possible paths that will comply with requirements. Firstly, explore the possibility of having the power company, or POCO, install a disconnect in the pad mount transformer. A high voltage disconnect on the primary side could potentially be a more cost-effective solution, even if purchasing the disconnect is necessary compared to installing a large disconnect on the secondary side. Secondly, directly engage with the AHJ to understand their preferences and requirements. As the ultimate authority, their input can save time and money by providing a clear path forward. The AHJ may require a service disconnect or a reduction in the length of the service entrance conductors. A disconnect might be the easier and more cost-effective solution in the long run. Consider leveraging the disconnect to gain access to the transformer terminations, assuming it's a pad mount type. This might be acceptable to the AHJ. If the service entrance is 1600 amps, the building's load is unlikely to consist mainly of lights and receptacles. Therefore, you might be able to propose that the disconnect also serves as a means of isolating the transformer. This could potentially lead to the AHJ approving a smaller disconnect on the secondary side. It is not common to see a power company install a disconnect on the secondary side of their equipment. Propose your intended solution to the AHJ and actively seek their input. The AHJ is more likely to be helpful and collaborative than confrontational. Service entrance conductors connect the serving utility to the customer's service equipment. The National Electrical Code, or NEC, provides guidelines for the length of these conductors and the placement of the service disconnect. The service disconnect is required to be readily accessible and located at a specific point, typically near the entry point of the service conductors into the building. The purpose of this disconnect is to allow for the complete isolation of the building's electrical system from the utility supply in case of emergencies or for maintenance purposes. The length of the service entrance conductors is a critical factor because excessive length can lead to voltage drop and increased impedance, which can negatively impact the performance and safety of the electrical system. The NEC addresses these concerns through various articles and sections, including those pertaining to service equipment and overcurrent protection. When the AHJ determines that the service entrance conductors are too long, it means they believe the installation does not comply with the NEC requirements, potentially compromising safety and reliability. The AHJ role is to enforce the NEC and other applicable codes to ensure that electrical installations are safe and meet the required standards. In this scenario, the AHJ decision after the plan review might seem consistent, but it is not uncommon for issues to be identified during the actual installation phase that were not apparent during the review process. The commentary in NEC section 230.70 provides additional guidance and interpretations of the code requirements for service equipment. Consulting this commentary can help clarify the intent of the code and identify possible solutions. Exploring the option of having the power company install a disconnect on the pad mount transformer is a viable strategy. Power companies often have the capability to install and maintain equipment on their side of the service point, including disconnects. A disconnect on the high voltage side of the transformer could be a smaller and more cost-effective alternative to a large disconnect on the secondary side. However, this would require coordination with the power company and may involve additional costs for the installation and maintenance of the equipment. Approaching the AHJ to discuss the issue and potential solutions is crucial. The AHJ can provide valuable insights and guidance on what specific measures would be acceptable to meet the code requirements. By understanding the AHJ concerns and preferences, you can tailor your approach to address their specific needs and increase the likelihood of a favorable outcome. If the AHJ requires a service disconnect, consider its location and accessibility. The disconnect should be readily accessible to authorized personnel and located in a safe and convenient location. The disconnect should also be appropriately sized for the service and have the necessary interrupting capacity to handle potential fault currents. If reducing the length of the service entrance conductors is necessary, explore options for rerouting the conductors or relocating the service equipment. This may involve additional construction work and costs, but it can ensure compliance with the NEC requirements and improve the overall performance and safety of the electrical system. Using the disconnect as a way to gain access to the transformer terminations can be a persuasive argument for the AHJ. This can facilitate maintenance and troubleshooting of the transformer and ensure that the electrical system is properly maintained over time. If the building's load consists primarily of equipment other than lights and receptacles, it may be possible to justify a smaller disconnect on the secondary side. This would require a detailed load calculation to demonstrate that the disconnect is adequately sized for the actual load. Proposing that the disconnect also serves as a means of isolating the transformer can be a valuable selling point. This can provide an additional layer of safety and convenience for maintenance and emergency situations. Power companies typically do not install disconnects on the secondary side of their equipment, but it is worth exploring the possibility. The power company may be willing to consider this option if it provides a benefit to them or improves the overall reliability of the electrical system. Approaching the AHA with a well-thought-out plan and a willingness to collaborate is essential for achieving a successful outcome. By demonstrating a commitment to safety and compliance, you can build trust with the AHA and increase the likelihood of a positive resolution. The NEC is a comprehensive set of standards that govern the safe installation and operation of electrical systems. Compliance with the NEC is essential for protecting people and property from electrical hazards. The AHA plays a critical role in enforcing the NEC and ensuring that electrical installations meet the required standards. The service entrance conductors are a critical component of the electrical system, providing the connection between the utility supply and the building's electrical distribution system. The length of these conductors is a key factor in ensuring the safe and reliable operation of the electrical system. The service disconnect is a vital safety device that allows for the complete isolation of the building's electrical system from the utility supply. The disconnect should be readily accessible and located in a safe and convenient location. Engaging with the AHA early in the process and seeking their input can help avoid costly delays and ensure that the installation meets their requirement. Collaborating with the power company to explore alternative solutions can also be beneficial, as they may have expertise and resources that can help address the issue. A thorough understanding of the NEC requirements for service entrance conductors and disconnects is essential for ensuring compliance and safety. Consulting with qualified electrical engineers and contractors can provide valuable insights and guidance on how to address specific challenges. A detailed load calculation can help determine the appropriate size of the service disconnect and ensure that it is adequately sized for the actual load. Proper maintenance of the electrical system is essential for ensuring its continued safe and reliable operation. Regular inspections and testing of the service entrance conductors and disconnect can help identify potential problems before they become serious. The NEC provides specific requirements for the installation and maintenance of electrical equipment in commercial buildings. Compliance with these requirements is essential for protecting people and property from electrical hazards. The AHA has the authority to interpret and enforce the NEC requirements in their jurisdiction. Their decisions are based on their understanding of the code and their assessment of the specific circumstances of the installation. The service entrance conductors must have adequate ampacity for the intended load, in accordance with NEC Table 310.15b16. The overcurrent protection must not exceed the ampacity of the conductors. The service disconnect must be rated to interrupt the available fault current at its terminals. Service entrance conductors must be installed in a raceway or cable that provides adequate physical protection. The service disconnect must be clearly labeled to indicate its purpose and function. The location of the service disconnect must comply with the NEC requirements for accessibility and working space. Service entrance conductors must be properly grounded and bonded to ensure electrical safety. The AHA may require additional inspections and testing to verify compliance with the NEC requirements. The service entrance conductors must be properly supported and secured to prevent damage and strain. The service disconnect must be installed in a manner that prevents accidental operation. The service entrance conductors must be protected from physical damage and environmental factors. The service disconnect must be maintained in good working order and free from defects. The AHJ may require the use of specific types of equipment or materials to ensure compliance with the NEC requirements. The service entrance conductors must be installed in accordance with the manufacturer's instructions and specifications. The service disconnect must be installed in a manner that allows for safe and easy operation. The service entrance conductors must be properly terminated and connected to the service equipment. The service disconnect must be properly grounded and bonded to ensure electrical safety. The AHJ may require the submission of detailed plans and specifications for the electrical installation. The service entrance conductors must be installed in a neat and workmanlike manner. The service disconnect must be installed in a location that is free from obstructions and hazards. The service entrance conductors must be protected from exposure to corrosive substances and environment. The service disconnect must be installed in a manner that prevents unauthorized access. The AHJ may require the use of specific types of overcurrent protection devices to ensure compliance with the NEC requirements. The service entrance conductors must be installed in a manner that minimizes the risk of electrical shock. The service disconnect must be installed in a location that is readily accessible to qualified personnel. The service entrance conductors must be protected from damage caused by rodents and other pests. The service disconnect must be installed in a manner that prevents the accumulation of moisture and debris. The AHJ may require the installation of additional safety devices to protect the electrical system and its occupants.